supported beam. If you are observing the simply supported beam, the reaction forces for the both ends is nothing but RA and RB. So I could not consider that reaction forces. It is the shaft is rotating with respect to some bearings. So both ends are having bearings. If any load is acting on the vertical direction, so automatically it is subject to some bending. It look like a U shape. So clearly observing that W load is acting on a body in the top side, the A should be having high stress as compared to the B1, because if W load is acting on the opposite direction, on top side direction, the top portion should be subject to the compression. The bottom portion is subject to the tension. I repeat once again, remember carefully, it is circular shaft. Whenever the load is acting on a body, then it is look like a U shape, means sagging will be take place. In the sagging itself only, the top portion should be subject to the compression, the bottom portion is subject to the tension. So therefore, the top portion is considered as I can taken as a point is nothing but capital A. The bottom point is nothing but capital B. Be subject to the compression forces or compressive stresses. Then capital B should be take place for the tangential forces. This is first case. Whenever the half revolution will be take place, means the A should be coming to the downward direction, B should be coming to the upward direction, which means that the position should be changes depending upon the half revolution. At that situation, the top portion is also compressed to the subject to the compression. The bottom portion is subject to the tension, which means that A should be coming to the B position and B should be coming to the A position. Then on the case of half revolution, A should be tension, B should be in the compression, which means that automatically the point A will be half revolution, it is subject to the tension, half revolution it is subject to the tension, so compression. Then B point is also half revolution is subject to the tension, half revolution is subject to the compression. So whenever the body is subject to the both tension and compression, the material should be failed below yield point, means there is no hint point should be failed depending upon the external forces. That type of the forces is known as cyclic stresses or completely reverse stresses. It is very much important. Let us take one example. Take any rod or any bamboo, apply the force towards yourself, it look like a U shape of the body. Then again opposite to the your body, then again you can U shape of the body. If you are clearly observing on the top surface of the bamboo, if you are bend the body that is bamboo towards yourself, so it look like a outer surface is acting on the tension, the bottom surface is acting on the compression. If you apply the body or forces acting on the bamboo in the reverse direction, so your side is nothing but tension and opposite side of that body is nothing but compression, which means that the portion should be always changes depending upon the direction of the forces acting on a body. Even though you can apply completely forces continuously, we don't know where the material will be failed. Means that the yielding means the failures occurs without any hint point, means below the yield point. So automatic material will be failed. This type of the forces is known as cyclic loading or reverse completely reverse forces. That is very much important of this one. So it is only possible depending upon the cyclic loading acting on a body, which means that whenever the body is rotating member, so always the load is acting vertical direction. So half revolution it is subject to the compression, half revolution it is subject to the tension, which means that it is the body should be moving up and down direction depending upon the load acting on a body. Means the body is subject to some bending loads or bending stresses. Automatically it is rotated with respect to some wheeling speed. Wheeling speed means nothing but the shaft should not be rotating in the constant speed. It is rotating with some loop type. Means the body is permanent deformation will be take place. Automatically it should be subject to some bending. U shape of the bending will be take place. The same U shape will be rotating in type of the loop form. So that means that the center of the rotation should not be coincident with center of the body. So once that body is take place, automatically critical speed will be take place. That critical speed is nothing but wheeling speed. So to avoid that one is nothing but had to analyze. You had to analyze the stresses acting on your body depending upon the cyclic loading should be acting on your body. So that is a very much important body. That is very much important. So clearly observing that a rotating beam will be have taken. That should be rotated in the mission. A load is acting vertical downward direction. The point A is having the top surface of the body. Point B is having bottom surface of the body. So first, the load is acting on point A. The point A is subject to the compression. Point B is subject to the tension because it is bottom portion. So under tension. So therefore, point A is under compression. Point B is under tension. So after half revolution, automatically B occupies the position of point A, then A occupies the position of the point B. In that cases, it is completely reverse, which means that in the first case, point A is compression, point B is tension. In the second case, whenever after completion of the half revolution, B is now under compression stress and A is under tensile stress. The speed of the variation of these stresses depending upon the speed of the rotation of the beam or rotation of the component. So that should be always changes depending upon that one. This type of the stresses are known as reversed load or completely reversed load or cyclic load. This is very much important of the body depending upon this one. There are number of stresses are acting on a body. The first one is nothing but the stresses which vary from minimum value to maximum value of the same nature, which means that point A is acting tension first time, point B is acting compression in the second time of revolution. Clear? So that means that point A is always acting tension on the top surface after one revolution. Calculate the value, we'll get that whether it is compression or tension. So that value will be one time is a maximum value, sometimes it is a minimum value. So the variation of the value depending upon the maximum or minimum with respect to whether it is in the same position, either whether it is top surface or bottom surface, that type of stresses is known as the fluctuating stresses. Clear? That's top of the stresses is nothing but fluctuating stresses. Similarly, one more stress is very much important. I want to calculate the stresses from the 0 to the maximum value, whether it is compression or tension. Sometimes compression value will be more, sometimes the tension value will be more. I want to calculate the maximum value should be depending upon the tension or compression. From the 0 value, we'll get that value is known as the repeated stress. Then one more is nothing but the stresses which vary from minimum value to maximum value with respect to opposite nature, whether it is tension or compression. So that is known as alternative stresses. Okay, so that is very much important to calculate all the values depending upon the load acting on